All right, so what we're going to look at now is slope. And you started looking at this with the parameter changes on linear parent function. What I want to do is I want to identify the slope in a linear function, be able to graph it also, and interpret its meaning. Now we're just going to do a little bit with the interpreting the meaning, but we're probably going to do a lot more with identifying the slope and seeing how you can graph it, or how it helps you with the graph. Okay, so the definition I would come up with for slope is the constant rate of change of a linear function. That key is on the words constant rate of change. You're going to hear me say rate of change or slope a lot interchangeably. The constant means that, like, if you're going up and over an amount, you're doing it the same each time. So the thing we want to make sure, though, that you understand, or I want to make sure that you understand, is that it's easier if it's expressed as a fraction. I know some of y'all are like, I hate fractions, I don't get fractions, and whatever. Deal with it. Here, these fractions are like a set of directions. So every time you see slope, you need to express it as a fraction. So keep in mind that when you do that, we talk about the top number, the numerator being the rise over the run, the denominator. Which means, what that means is the vertical change, how much you go up or down over the horizontal change, how much you go to the left or to the right. You might sometimes even see this with a special symbolic notation of like a triangle y over a triangle x. The triangle means change in. So change in y over change in x. It's actually a Greek letter known as delta. But the whole point of that is to, again, see how you can move it up or down. So you go from a specific point and you work your way to the next one. Okay, so here's the parent function, y equals x, or 1x. Now, notice there, the slope is 1. M is what I say is the slope. So remember, on your paper yesterday, or on the parent parameter changes, they were talking about what's the m in front of the x. That's the number in front of the x is always your slope. And I would rewrite that 1 as 1 over 1. That, again, is known as a rate of change, the rise over run. And that means, like, if you take a point, you're going to go up 1, you rise 1, and run across to the right 1. Up 1 over 1, up 1 over 1, up 1 over 1. Each and every single time. That's all you're really doing with that. So you kind of have to kind of keep that in mind, that that's telling you how much you're going up and across. Okay, here's another example. Y is equal to 2x. So what's the slope? If you look at this equation, again, the number in front of the x is the slope. That's your m. M is the symbol for slope. So that starts with a 2. Now again, expresses as a fraction. So let's say that 2 over 1. That would tell me that I'm going to go up 2 and over 1. Now notice that I'm going to start in the middle. And you should know from your worksheet earlier what changes that point where we start, because that's what's called our starting point, the y-intercept, and that's something we'll look at later, but right now we're just looking at slope. And this tells me that I'm going to go up 2 to the right 1. So you can see here I'm going up 2 over 1, up 2 over 1, up 2 over 1. Now, you should also know that it's not just going up 2 over 1, you could do the opposite of that, which would be negative 2 over negative 1. Now, notice, a negative divided by negative is still positive. So I could go down 2 to the left 1, down 2 to the left 1, down 2 and to the left 1. And if you notice, they're still all making a straight line. So the point there is you can say take what they give you, and you can also change the signs, but you got to change the sign for both numbers. So if they're both positive, you'll make them both negative. If one was negative and the other one was positive, you'll switch it around and change that. Okay? So we'll see some examples of all those. Okay, here I wanted to do one with already a fraction, because some of y'all were like, I don't know how to put a fraction in a calculator. Again, that's just division. But 1 divided by 3 here, that means this. Our slope is 1 over 3, which says I'm going to go up 1 and 3 to the right. So starting in the center, notice there I'm going up 1 and 3 to the right. Okay, again, I could do the opposite of that. So I could say also down 1, negative 1 over negative 3, and 3 to the left. And you can kind of see how I'm counting those out and placing my dots. And notice, again, when I connect them, it still makes a straight line. All of these should still make a straight line. So you can see it's very important for slope to be written as a fraction because the top number tells me how much I go up or down, the bottom number tells me how much I go left or right. This next example, I decided to put in a negative, one that's already negative. Now when I write this slope, I'm keeping the negative with the top number. So negative 3 over 1. The slope is negative 3. Now that tells me I'm going to go down 3 and 1 to the right. So 1, 2, 3 down, and then 1 to the right, place my dot. 1, 2, 3 down, and 1 to the right, place my dot. I could do the opposite of that, change that negative 3 to positive 3, and change the positive 1 to negative 1. And that would tell me to go up 3 and 1 to the left. Up 3 and 1 to the left. Notice how it's still making that straight line. Okay, so there would be me graphing, say, the line with a slope of negative 3. Again, notice it is steeper, still going through 0, 0, then the parent function, but that's pretty much it for those. Okay, so here I have negative 2 over 3x, so that would tell me that my slope is going to be negative 2 over 3. I wanted to choose one where I didn't have a 1 involved this time because it's been a while. I haven't done that with any of the other examples. So here I'm going to go down 2 from this, again, the center, down 2 and 3 to the right. Oops, let's do that again. Okay, so you can see here, down 2 over 3, and I could do the opposite, up 2 over to the left 3. So notice how it still makes a straight line. That's very key. Okay, very simple to work with. So what we can see here is that with your slope, the top fraction will tell you to go up or down. A positive number tells you to go up, a negative number tells you to go down. The bottom number tells you to go left or to the right. A negative number tells you to go to the left, and a positive number tells you to go to the right. So that's something that might be useful to put onto a note card. Okay, so here I've got one where I want you to, say, figure out the slope. Now, I try to draw this as best I possibly could, but all you got to do is find, like, say, 2 points. Any 2 points. See, I'm going down 1 over 2. So that means my slope would be negative 1 over 2. I don't care about the y-intercept or anything like that. That's something we'll worry about later. But right now I'm just trying to find the slope. And you can see here I'm kind of confirming that all of those are down 1 over 2. Now, what I would challenge you is this. Here's 2 points that are on that line. See if you can find a way to get those 2 points to equal that negative 1/2. Think about that. Okay? Think about that. The whole thing is about talking about a change in the y over the change in the x. I'll give you kind of a hint later on about this. Also, let's keep in mind this. I could have gone down, I'm going to do this in a different color. I could have gone down, let's say, pick this point, and let's say I pick this point. I go down 1, 2, 3, 1, 2, 3, 4, 5. Actually, 1, 2, 3, 4, 5, 6, sorry. So I went down 3 over 6. Well, when you simplify that fraction, you get negative 1/2. So you can see no matter what 2 points you pick, they should simplify to the same fraction. And you could kind of keep in mind the idea that we're talking about the change in the y over the change in the x. Which means, if you think about it, take your y points, what would you do? Change, would you add or subtract? You should subtract. Subtract your x's. It doesn't matter technically the order, but usually you might see it like this. See if that helps you see how to get that to equal that. Okay, for my last example, I'm going to talk about how we can interpret the meeting here. So you notice here I've got 2 points drawn out. Try to do it as best I could, so kind of freehanding it. But the key here is not the points, but what these stand for, the distance and the time. Now, if I go follow the path, the rise, I can go up 40, and then I go over 3. Measure that, that means the slope is 40 over 3. 40 miles, 3 hours. We'll say miles and hours. Now, you could divide that out to a decimal if you wanted to and get 13.3 over 1. But notice here, I'm still writing that slope as something over 1. So even though I let myself get a decimal answer, I still want to put it over 1. And the reason why is because that tells you something. This tells me, this one right here is telling me I traveled 40 hours or 40 miles in 3 hours. This one saying the same thing, but means I'm traveling an average distance of 13.3 miles for each hour. Okay, so I'm going about 13.3 miles for every hour, or 40 miles in 3 hours. The biggest difference between those, honestly, is that with this one, that 13.3 over 1, is also known what is called a unit rate. It's the same thing, it's expressing the same thing, but it's trying to express it in terms of 1 hour. A unit rate always wants an answer of 1 here on the bottom. So kind of keep that in mind. I mean, they're saying the same thing, but one is just, I guess, supposedly a little bit more specific than the other. Now here I wanted you to see, look, if I had taken the 70 and 30, my 2 points, and subtracted them, what do I get? 70 minus 30 is 40. 4 minus 1 is 3. Well, that was the slope that we caught in the previous problem. That was telling me 40 miles for 3 hours, or 13.3 miles, sorry, not 13.1. Was it 13.1? Hold one second. Oh yeah, 13.3. So this should have been 13.3 miles per 1 hour. Okay, so what does that mean? You got to be careful when you see this on a test or something. When you see something like that, make sure that they're asking for the slope, and if there are, then understand what you're trying to say there. All right, that's it for slope. If I do need to add anything else, I will let you know. Thank you very much.